Okay, guys, we are getting ready to start a new chapter, chapter 4, which is exponential and log functions. One of the best parts about college algebra is that we get to look at every type of function and we look at them relatively quickly, which helps us make comparisons, I think. We, of course, have been looking at linear functions like y equals x since Algebra 1. And then in the end of Algebra 1, Algebra 2, we go into the quadratic function, y equals x squared. We see what that looks like. We study the square root function, right? When the domain's restricted just to positive numbers, y equals the square root of x is this green one. We study the absolute value function, similar to the quadratic, except it's we're not squaring something, but everything does become positive, and that ends up giving us this V shape. Last section, we talked about polynomials, right? Y equals x cubed. Then we know that since it's a third degree, we're going down to the left and up to the right. Okay. We saw what happened when it was x to the fourth. Then it's kind of like x squared in that both are going up. The end behavior is up in both ends, right? The limit is positive infinity in both as x approaches infinity and negative infinity. X to the fifth, we end up again with this, as x approaches negative infinity, y approaches negative infinity. As x approaches infinity, y approaches infinity. Okay, all these different, we're trying to get you to understand what these look like. So when someone says they have a quadratic, or, you see that the biggest degree is 2, you're looking at something like this. Obviously, what adding and subtracting and flipping it does, or multiplying it by 2, etc. If you have a square root function, you're thinking this in your head. Okay, well, this new section, exponential functions, we want you to get a feel for what that looks like. Okay, so in your notes, I'm asking you to graph these 3 functions. Y equals 3 to the x, y equals 3 to the negative x, and y equals 1/3 of the x. Just like any time, guys, when you start and you're with a new type of function and you're not sure exactly what it looks like, just start plugging in some numbers. Okay, let's just plug in 0. Okay, y equals 3 to the 0. Well, 3 to the 0 is 1. Then plug in 1. Y equals 3 to the first. Then we have 3. Plug in 2. Y equals 3 squared. That would be 9. Plug in 3. That's going to be 27. You start realizing, oh, that's too big for me to graph, but I can tell that the bigger numbers I put in, the bigger y values I get. So let's see what's happening on the negative side. What is 3 to the negative 1? All right, be careful. 3 to the negative 1 is not negative 3, is it? 3 to the negative 1 is 1 over 3 to the 1, or 1/3. 3 to the negative 2 is 1 over 3 squared, 1/9. 3 to the negative 3 is 1 over 3 squared. I'm sorry, 3 cubed, 1 over 27. So if I plot this, I know I have 0, 1. 1 gives me 3. 2 gives me 9. Negative 1 gives me, oh, it's kind of hard to do, negative 1/3. Oh, I'm getting closer and closer. I'm always going to have 1 over something. So you start realizing that you get this kind of curve that starts out very slowly, but it gets bigger. It goes through 0, 1 and shoots off, right? What's different when I do y equals 3 to the negative x? Well, 0 is still going to give me 1, right? 3 to the negative 0. That's still 3 to the 0, which is 1. However, 1, if I put 1 in for x, that's 3 to the negative 1. So 1 gives me 1/3. 2 gives me 1/9. That's kind of the opposite of what's going on here. However, if I put negative 1 in, 3 to the negative 1, that's 3 to the 1, which is 3. So negative 1 gives me 3. but 1 gives me a third. I have the same type thing, but it's reflected across the y-axis. That's what 3 to the negative x looks like. 3 to the x is this increasing function. Whoops. See how I keep increasing as I get, it's constantly increasing, but 3 to the negative x is decreasing. The bigger x gets, the smaller y gets. That's decreasing. What happens if it's 1/3 to the x? Well, 0 is still going to be 1. 1 gives me 1/3 to the 1. That's a third. 1/3 squared is 1/9. Okay, if I do -1, 1/3 to the -1 is 1/1/3. Well, that's 3. -2, that's 1/1/9. Well, that's 9. I don't know if you noticed, but it's the exact same graph as the red one. Whether I say 1/3 to the x or 3 to the negative x is basically, they're the exact same graph. Okay? Does that make sense? So I hope you got those graphed nicely. If you didn't, let me just, I think I have them graphed here for you. Here you go. I tried to graph them nicer. Y equals 3 to the x is this red graph. Y equals 3 to the negative x is the blue graph. And y equals 1/3 to the x is going to be a green graph. And watch, it'll be the same one as the blue. See it? Whether I take the green one away, put it back, they're the same. Y equals 3 to the negative x and y equals 1/3 to the x is the same graph. Okay? All right, so that's an exponential. So when you see by exponential, I mean that the variable is in the exponent. I have people that sometimes say, well, why isn't y equals x cubed? That's an exponential function. No, that's a cubic. That's a third-degree polynomial. The exponent is 3. Here, the exponent is the variable. That's what makes it an exponential function. Okay, let's think about the domain and range of these things. As you saw, I was putting 0 in. I was putting negatives in. I could put fractions in. I don't really feel like 3 to the 1/2, that would mean the square root of 3. I can do that, right? So the domain is all reals. Okay? For both these. I can put positives, negatives, 0. I can put anything I want. The range, however, what was the range of these? What kind of y values are coming out of these? Right? Positive numbers. You see it? The y values that were coming out are positive numbers. And 0 wasn't included. No matter how small I get, I'm not going to get to 0. So it's going to be 1 over something. So the range is 0 to infinity with a parenthesis. Please put a parenthesis. The 0 is not included. You're never going to get 0. You know, even if I have negative 100 in here, that's 1 over 3 to the 100th. That's very tiny, but it's not 0. Okay, and as we said, y equals 3 to the x is always increasing. There's no spot where y equals 3 to the x becomes decreasing. And in contrast, y equals 3 to the negative x is always, sorry about this, my writing, always decreasing. Okay, sorry about my writing. I don't have my pen. I lost it. Always increasing, always decreasing. Okay. I think in your notes, maybe on the next page, I asked you this limit questions. I put it all here on the one Smart Notebook file, but I think in your notes, it's on the next page. But when I say what's the limit as x approaches infinity, what that means, guys, is what's happening to y as x gets bigger and bigger and bigger and bigger. Okay, so let's look back at our graph. What is happening to y let's look at the red graph, y equals 3 to the x. the bigger x is getting, the bigger y is getting, correct? As x gets bigger and bigger, y gets bigger and bigger. So the answer to the limit as x approaches infinity of y equals 3 to the x is infinity. What's the limit as x approaches negative infinity? In other words, what's happening to y as x gets smaller and smaller and smaller? Well, on the red graph, I see that as x gets smaller and smaller and smaller, the y-coordinates aren't approaching negative infinity. They're approaching 0, right? I'm getting closer and closer to 0, but I'm never actually going to be 0. But that still is my limit. The limit of y equals 3 to the x as x approaches negative infinity. As x gets smaller and smaller and smaller, my y is approaching 0. And for 3 to the negative x, it's the exact opposite. Okay, let's look at the graph. Now I'm looking at the blue graph. As x is getting bigger and bigger, 2, 4, 6, 8, getting bigger and bigger, my y is getting really close to 0. Okay, the exact opposite things happen. And as x gets really, really small and negative, my y is getting closer and closer to positive infinity. Okay, so the limit as 3 to the negative x approaches infinity, that's 0. The limit as x approaches negative infinity, that's positive infinity. Okay, so the limits are the exact opposite depending if you're talking about 3 to the x or 3 to the negative x. Okay? All right, now let's graph these functions. See what you think here. Think about what 3 to the negative x looks like. Okay, it usually goes through 0, 1, and it's decreasing. I'm just doing a rough sketch. Okay, think about what adding 1 did to any of our functions before. Just last chapter, we were talking about transformations of functions. Well, this is the same thing's going to happen. Okay, I am going to take this. It's basically going to be shifted up 1, right? I mean, that doesn't look like the nicest graph in the world, but that's what's going to happen. Okay, I know what it looks like before I even start plotting points. But if I want to, I'll put 0 in. 3 to the 0 is 1. 1 plus 1 is 2. I'll put 1 in. 3 to the negative 1 is a third. A third plus 1 is 1 1/3. I'll put negative 1 in. 3 to the negative 1 is 3 plus 1 is 4. So I'll graph negative 1, 4, 0, 2, 1, 1 1/3. Okay, anyway, this is the graph you get. It's just like 3 to the negative x, but it's shifted up 1 on the y-axis. 1 minus 2 to the x, I might rewrite that as negative 2 to the x plus 1, just so I can see that my 2 to the x, which usually looks like, oops, oh, that doesn't look like that. 2 to the x. Think about what that looks like. It's not 2 to the negative x. It's just 2 to the x. Sorry. Okay, so 2 to the x looks pretty much like 3 to the x. I mean, I'm just giving you a general sketch. The negative in front, remember what a negative in front does? It reflects it across the x-axis. So this is going to be instead going like this. It's reflected. It turns it upside down just like the parabola. But then I'm also going to be shifted up 1. Okay? So I'm going to be shifted up 1 besides that. All right? So let's, think about what that looks like. Graph that. And then come back for video part 2 and see if you were right. Okay? See you in a couple minutes.